If f of x equals 3x plus 4 divided by 6 minus x, and g of x equals x minus 1 over x plus 2, then determine f of g of x. Simplify your answer. So this is a composition of functions. This f of g of x, we can write that as well as, it can be rewritten as f of g of x, like that. And we know what g of x is, so we can replace the g of x with x minus 1 over x plus 2. So we're going to get f of x minus 1 over x plus 2. And now this is our argument for function f. So as we expand function f, this one right here, we're going to replace the x's with this quotient. Okay? So it's going to be 3 times x minus 1 over x plus 2 plus 4. And then in the denominator, it's going to be 6 minus x, which is x minus 1 over x plus 2. Okay. Now, in order to proceed here, we want to add these two terms in the numerator, subtract these two terms in the denominator. Whenever we're adding terms that include quotients, we need to make sure we have the same denominator. So here our lowest common denominator, both in the numerator and in the denominator, is going to be x plus 2. So we can go ahead and rewrite this, x plus 2. So we can go ahead and rewrite this using a common denominator. And that means we're going to put it on the same division line as well. So this division line here, this division line here is going to be this division line here. Okay? And the numerator, we're going to have another division going on. And we're going to get 3 times x minus 1 plus 4 x plus 2. And the denominator is just x plus 2. In the denominator, we're going to get 6 times x plus 2 minus x minus 1. And in the denominator, we have x plus 2. So this is how it looks now. Sorry. We can now expand the numerators, multiply in the 3 and the 4, and combine like terms to simplify it. So we're going to get 3x minus 3 plus 4x plus 8 over x plus 2 divided by 6x plus 12 minus x plus 1 divided by x plus 2. And we can now combine like terms. We have 3x plus 4x, that's 7x. We have negative 3 plus 8, that's 5. X plus 2. 6x minus x is 5x. 12 plus 1 is 13. X plus 2. Okay, so now what we have here, we have division involving quotients both in the numerator and the denominator. When we're dividing quotients like this, we can convert this to a multiplication. So we're going to get 7x plus 5 over x plus 2. And instead of dividing, now we're going to multiply by the reciprocal of the quotient in the denominator. So x plus 2, 5x plus 13. And here the x plus 2 cancels this x plus 2, leaving us with 7x plus 5 divided by 5x plus 13. So that will be the final answer in terms of simplification. The only thing we need to do before we wrap it up is we need to identify the non-permissible values, because these are rational expressions. Okay, so there's a few here. So we have here we have 5x plus 13, our non-permissible value here. If we equal this to we can do this, 5x plus 13 equals to 0, and that's going to happen when x equals 13 over 5. So minus 13 over 5 actually. So x cannot equal to negative 13 over 5, because we'll end up with a 0 in the denominator. And now what we have to do, we have to go backwards all the way to the beginning and check if there's any additional non-permissible values. And we can see that we have x plus 2 in the denominator throughout here. So that's going to be another non-permissible value of negative 2. And then if we go all the way to the beginning, we see that where is it? Here we have 6 minus x. So technically x cannot equal to positive 6. That will be another non-permissible value, but because we replace that with the function g, that non-permissible value disappears. And if we look at this, this basically replaces the x right here. This is function g. We have the non-permissible value of negative 2. Okay, so there's only 2 non-permissible values.